Okay. So let me start. If you have any specific queries, you can ask, or I can start myself. Do you have any specific doubts? Okay, then I can start, right? So I was actually discussing, I started discussing on the I section. So how to solve it? I will quickly start that. Say there is, I think in your assignment, there was a question how to determine the moment of inertia of the I section about its centroidal axis. Okay, in the assignment 2. Assignment 2, I think question number 12. Question number 12 and 13, there were two questions. One was about the I section, another was about the another was for the T section. So I section, I will just show you how to do it. So it is like this. Dimensions were given. Now dimension was given as, say, so here it was 100. All are in millimeter. So I'm not writing that. Next, we have to determine the moment of inertia of the given figure shown. So it is written. Actually, you have to determine about its centroidal axis. Okay, so let me write that. Determine the moment of inertia or area moment of inertia. It will be better to be precise. Area moment of inertia. So MOI about the centroidal axis parallel to the base. The base. What is the meaning? Base is this line. This line is the base. This is the base. This line is the base. So the axis which is parallel to this base and passing through the centroid. Now, let me ask you that whether do you know the centroidal position for this, first of all? Because since it is a doubt clearing, so I think it should be good that if I interact so that your doubts will be clarified. First of all, if anyone has any doubt, please ask. That means for this section, what we know and what we do not know. That means what we know and what we have to determine. That is the question. What we know is that dimensions are known. That means the shape is known. But this shape, you see, that is not a regular shape. That is the first thing that you have to identify. That is not a regular shape, but it can be seen as composed of some regular shapes. Composed of regular shapes means regular shapes. What are the regular shapes? Say, for example, rectangle, square, triangle, circle, semicircle, quarter circle. These are basically the known figures, known shapes for which we readily know the centroids. But for this, we do not know what is the centroid. That means this composite figure, we do not know where is the centroid. Okay. So therefore, what we have to do? We have to determine the centroid. That is the first thing that we have to do. Okay. So that thing you have to first identify. That we do not know the centroid of this figure, we have to first determine the centroid. Okay, that is the first thing that we will do. Okay. Next thing is that what we know, or for what, or for which object we know the centroid, that we will see first. So here, first let us identify those parts for which we know the centroid. Okay. So okay, okay, right. So let us identify that. So this is one shape for which we know the centroid. This is a regular figure, that is a rectangle. Again, there is another line which we can draw here, which will demarcate another regular shape like this, for which we can easily determine the centroid. And another shape for which we can again easily determine the centroid. First of all, is this clear? This step, that means it is a composite object, as if now we are decomposing it into regular shapes so that we can identify their centroids and then follow the rule of determining the centroid of the composite object. Okay, that is a kind of divide and conquer, means kind of strategy. Okay, so that we are going to do. Okay. Others are trying to join. I actually do not know whether someone else. Okay. So now the thing is that here, what is the centroid of this shape shaded with magenta? Where is the centroid? We know it, right? We will mark it. So this is say area 1 and the centroid is say C1. This is the area 1 and the centroid is C1. So this is area 1 and this position is C1. Then we have this is area 2 and centroid of this area we know centroid is C2. And then we have the third area, that is area 3, and then we have centroid 3. So for this problem, the first job will be to determine the centroid of the composite object. Now first let us uh, uh, make a table so that we can write properly the values. So let us do that. So there will be basically first thing is area. So serial number, then area 1, 2. Then we have basically the centroids, that means x coordinate, y coordinate, like that. So we will first write that. Okay. So that is the thing that we will do first. So that means first serial number. Then we have area, value of area. Then value of x coordinate, and then value of y coordinate. Although x coordinate is not needed because x is always on the center line. This is symmetrical object. But for some object like L shape or Z shape, means L shape, and then you have C shape, we do not know the centroid, means x coordinate. So for those shapes, since they are not symmetrical, in that case, in those cases, the x coordinate also will be needed to be determined. Okay. So this is the x coordinate and this is the y coordinate. Okay. Therefore, we will do that. So serial number, this is 1, 2, and 3. Then we have area. So serial number means what? I, value of I basically. Area, AI. Then centroid, centroid of AI, x coordinate of the centroid. X coordinate of the centroid of AI. Then y coordinate of the centroid of AI. Right? So that is what basically xci, we will write that. This is nothing but xci and this is yci. So xci is equal to the x coordinate of the centroid of AI and yci is the y coordinate of the centroid of AI. And this is I, this is AI. Okay, this is AI, this is I. So I is equal to that is written in this table. AI is equal to written in this table. XCI is written here and YCI is written here. So first of all, what is AI? That means for 1. So for this magenta shape, what is that? Can you tell? So it is 200. Yes. 200 by, right, 200 multiplied by 40. So 200 multiplied by 40 is equal to 8,000 millimeter square. Right? Thank you. Next, A2. Okay, first let us identify all the corresponding values for I is equal to 1. So XCI is where? Say if I consider this is the center line or the means the this is the, say for example, the axis. This is the axis, then it will be on the center line itself. So it will be 0, isn't it? Because this is, say for example, x-axis. If this is x-axis, if this is x-axis, then the x coordinate of the centroid will be 0. And where is the y coordinate? Y coordinate we will determine. So y coordinate will be on this direction. somewhere. So this is say x y direction, and this is x direction. And maybe I have told wrongly. This is the x direction, so x coordinate will be on this, that is 0, 0, and y is this direction, so y coordinate will vary. Okay, is it clear? X coordinate will be 0, but x axis is this one. X axis is the line along the base. Okay, clear or not?
Yes, sir. Yes.
Okay, means I want you to interact so that it becomes a nice doubt clearing class. Otherwise, it will be just like your means classroom class, and you will just follow whatever I tell. Maybe you will be able to understand or not. I cannot understand. Okay, please interact if you have any doubts. So next we will write XCI. What is XCI for this? XCI is 0, right? 0 mm. And what is y coordinate of the centroid for AI? For A1? Y coordinate will be, for this magenta, it is 40 millimeter wide. So what is the y coordinate of this? It is here. So it will be 20 exactly. So it is 20 mm. Okay. Uh, Actually, I am at home, so there are some sounds coming from here and there. Please ignore all this. 20 mm is this one, 20 mm, right? This is the centroid for the shape Y. So it is 20 mm. I think you can easily understand that this is rectangle, so it is midpoint of the width. Next, for shape 2. So I will use a different color for this so that you can follow, correlate. So for this area 2, so what is the area? Area is, this is 100 multiplied by 30. So area is 30. I am following the x multiplied by y so that it remains similar. 30 multiplied by, this is width is 30. Okay. This width is 30, is this one. This width is 30 and this length is 100. So 30 multiplied by 100, isn't it? 30 multiplied by 100. So what is that? 3000 millimeter square. And what is the x coordinate of the centroid? Again, it is 0 because this is symmetrical object. X coordinate is 0. What is y coordinate? Y coordinate is, can you tell?
The 90. The 90.
Exactly 90. So that you have to understand, because this is the center or midpoint of 100, but midpoint of 100 from this line. This is 50, and then 40 you have to add for the flange. Right. So this is 40, and then, so it is better to write, I will write like 40 plus 100 by 2. So it will be easy for you to follow. It is equal to 90 mm. Isn't it? 40 plus 40 plus 100 by,
Sir, can you explain this part once more?
yes, sure. You see that is the pointer visible properly?
Yes, sir. Yes.
Okay. So you see that this magenta color part area and this orange colored area rectangle. Okay. Next, I have identified the orange color rectangle. Now this is not aligned with the x direction, x axis. It is shifted from the x axis by a distance of 40 mm. So this orange color area, what is the centroid of this? So that centroid will be based on the length of this area. So what is the length? Length is 100. Next, 100 is measured from where? 100 is measured from this line. And this line is shifted from the x-axis by 40 mm. So the centroid of this is 50 mm from this point. Right? Centroid of this area is 50 mm because it is 100. So 50 mm measured from this part, this point. And this point is shifted from the x-axis by 40 mm.
Yes, I understood.
So 40 plus 100 by 2. So 100 is this one. So 100 by 2 is here. But we have to add 40 with this so that it is measured from the x-axis along the y direction. So origin is here, you see. Origin is the intersection point between the x of the x and y axis. So it is here. Therefore, 40 you have to add. Right? Okay. Anyone has doubt? So these are the crucial points for actually determining the x coordinate, y coordinate clearly. Otherwise, there may be some error, right? Okay. Next one is the third area. For the third area can be easily determined. It is 100 multiplied by 30 again. So it is 100 100 multiplied by 30. So 3000 millimeters square. Okay, next, what is the x coordinate of this centroid? X coordinate is again on the center line in the along the x, that means along the origin. So it is 0. And what is the y coordinate? Again, y coordinate will be the midpoint of this 30. Y coordinate will be the midpoint of this 30.
So 155.
Uh, uh, let me check. It is 40 plus 100 plus, yes, exactly. You are right. Exactly. So it is 40 plus 100 plus 30 by 2. So it is 155. So let me break that. So it is 40, sorry, yes, 40 plus 100 plus 30 divided by 2. So it is 155 millimeter. Now is it clear to all these dimensions? First of all, that should be first of all, that should be clear. Okay. Next, what we will do, we will just use the theory. Next. So what is that? Theory is that you see that x coordinate all are 0. Therefore, composite object also will have the x coordinate at x is equal to 0. There is no doubt. Right? Next, y coordinate. That is important. So we will determine the y coordinate. X coordinate will be all 0. Because xc of the composite object is equal to summation ai, I is equal to 1 to 3, I is equal to 1 to 3, and then on the top we have xci ai. I is equal to again 1 to 3. Okay. I is equal to 1 to 3. Therefore, it will be 0 because all these xi's are 0. So it will be 0 by that is a1 plus a2 plus a3. Because it is 0 into a1 plus 0 into a2 plus 0 into a3. So it is 0 all. Therefore, it is 0. So xc is 0. Now, what is yc? Yc is the same way. Yc we can write as summation I is equal to 1 to 3 yci ai divided by summation ai. So that is I is equal to again 1 to 3. So therefore, if we try to write, because we have already tabulated, we can now use that table. Okay. So therefore yc is equal to, now we will break this summation, we will break down. So it will be now yc1 a1 plus yc2 yc2 a2 plus yc3 a3. I have just break down it, the numerator. Excuse me, someone is trying to join. Let me allow. Okay. So here it is a1 plus a2 plus a3. Okay. Clear this part? So that should be clear. Next, what we will do, we will just put the values, nothing else. We have to just put the values. So let us put the values. So what is y1, yc1? Yc1 is this one, 20 mm, right? 20. So it is 20. For I is equal to 1, yci, so 20. So 20 multiplied by how much? Area 1. So what is that? 8,000. Plus next YC2 90, right? This orange colored 90 multiplied by 3,000 plus the third one 155. Please be ready with a calculator. 3,000. Okay. And in the denominator, we have these three. 8,000 plus 3,000 plus 3,000. So can you tell, can anyone tell what is the? So you see that this will be easily cancelled. So in the numerator you have 14 and in the denominator you have 20 into 8. 1,000 you can easily cancel, and then 90 multiplied by 3 plus 155 multiplied by 3. So uh, how much is it coming?
It's coming
51.07 mm. Okay, let us check. Is it possible or not? 51. So 40 and then it will be in between. So it is quite possible. So you can check once more and confirm. So 20 multiplied by 18, it will be 160 plus 270. 160 plus 270 plus 465 divided by 14. Okay, is it coming to be 51, right? YC. Okay. So let me mark them. First of all. So these are the things that we can identify. Okay. This is that XC is equal to this and YC is equal to this. Okay, next job is what? Next job is to determine the. Now, can you tell me where is that? XC, YC1. So let us just mark them. YC1 is 51. So it will be somewhere, say here. So it is 151. So it is somewhere here. It is somewhere here. Right. This somewhere here. So now, as I told in one of the videos that you can.
Sir.
Yes.
Sir, I think it's 192.
63. Okay.
Yeah.
Okay. 63.92. Let me correct. $63.92. 63.92 mm. Okay. So this is this 63.92. So you see that therefore the centroid is somewhere. Okay. So means 40 plus it is 90. So 63 can be means roughly can be shown here. So no problem. Only thing is that we have to first know this. So we have already known this. Next what? Can you tell? Next, our job is to go for determining the moment of inertia. So this job was to determine, the first job was to determine the centroid. So this is determination of the centroid first. So let me write it. First job is to determination of the centroid. First job is to determine the centroid. Determination of the centroid. Of the composite shape. This, the first job is this, determination of the center of the composite shape. Next job is determination of the moment of inertia of the composite shape. The next job. So let us paste it and solve it. Okay. So this is the determination of the centroid, sorry, moment of inertia. Area moment of inertia of the composite shape. So how to determine that? I told you that we can determine in two ways. One is by doing or using the parallel axis theorem. What is the parallel axis theorem? Can you recall? Parallel axis theorem is if I write uh, that it is I xx is equal to I x prime plus d square into area. This is parallel axis theorem. So if we use parallel axis theorem for this, how to do that? That means for all the areas, what is the centroidal coordinate? Let us mark that centroidal coordinate first. So we will mark it with red. So we will mark it with red. The centroidal coordinate we will mark with red. So now this is the centroidal coordinate. X coordinate and centroidal y coordinate is along this line itself. So we can just show along this line itself. That means the black and the red y axis are basically overlapping. So this is x coordinate. So let me mark that. So that is basically x prime and this red is y prime. Okay. So this is x prime, y prime for the whole object, not for the individual regular shapes. This is for the complete object. Okay. Next is that for all these shapes, there are centroidal coordinates, centroidal x coordinates. For all these shapes, that you have to understand individually. This is for the complete object. Right? This is for the complete object. Now, individually, if we try to apply, then how to do that? So, total moment of inertia will be the sum of moment of inertia of the individual shapes. Because you see that how to calculate the total moment of inertia. Total moment of inertia, if we calculate, say that I means what? What is the definition of I? Say about x-axis. What is the definition? It is basically y square dA. Right? It is over the area. Now this over total area, this area is how much? Basically, this area is nothing but summation AI y square dA. Now you see that this area can be written as for A1 y square dA plus A2 y square dA plus A3 y square dA. Therefore, we can write that this xx is equal to I xx1 plus I xx2 plus I xx3. That means what? Basically, if we try to calculate the moment of inertia of the complete object, if we want to determine the moment of inertia of the complete object, then individual moment of inertia, if we can calculate about some axis, then we just add this, we will get the moment of inertia of the complete object. Okay, first of all, this should be clear. That means when we try to calculate the moment of inertia of the complete object, we can break it down to the regular shapes and determine the moment of inertia of these, and then we can add simply them. We will get the total moment of inertia about the same axis. So this x-axis is same for all. That means if we try to calculate the moment of inertia of the complete object about any axis, then we will calculate the individual moment of inertia and then we will add. Okay. Is it clear? How is it coming? You see that xx is breakdown into this for A1, A2, A3, then we can simply add them. Okay. Clear? Is it clear?
Okay.
This is a crucial step that you have to understand. Otherwise, you will not be able to follow that why we are doing like that. So that is the logic that you have to understand. Simply adding them, we will get that. Okay. Next is that we will now calculate individually. So what is the target? Target is to determine the moment of inertia of all objects about this axis. So what we will do? We will calculate the moment of inertia about their centroidal axis, and then we will add this part. Add this part for individual objects. Okay. So that is the job. So this part will be now to be determined individually. So first of all, we will determine this part ix prime x prime for individual shapes and then add. So try to understand that. For let me do it uh, in a different diagram. So what is that? You see that we will draw the two axes. First, we will draw the black axis. So this is, say, this one, and then this is this one. So okay. Next we have an area which is like this magenta color area, say it is here. It is here. This magenta color area is here. And the red axis is where? Red axis is here. Sorry. The red colored axis is here. And another y direction for that is here. Okay. Now, what is this that you have to clearly understand? That this is the centroid of the composite object, but not for individual surfaces, individual shapes. So let us write. So here, for this object, what is the moment of inertia about the black axis? So this is x. This is x. This is x prime. So what is the moment of inertia about the black axis? Or the centroidal axis for this? Can you tell? Centroid is where? Here. And this is here. So what is the distance? 69 point, how much?
Okay. 63.92.
Oh, 63.92. 63.92. 63.92. 63.92 mm. And what is the centroid here? 20 mm.
20.
20 mm. 20. So therefore, what is this distance? Can you tell? What is this distance? 63 minus 20. That is 43.92. 43.92. That means from this center, I will move to this. From this point, I will move to this. I know the moment of inertia of this magenta color area about this point, C1. This is C1. So this is C1 and this point is C. C means the centroid of the complete object. So this is C. This is C. This one. Okay, am I clear? Am I clear? This is centroid of the complete object and these are individually C1, C2, C3 are the centroids of the individual shapes. So first, if you understand this part, then it will be easy to follow for all other shapes. So C1 is here and C is here. So we have to first move from C1 to C. We will apply this perpendicular axis, a parallel axis theorem. We will use this parallel axis theorem. So this is the parallel axis theorem that we will apply for this shape. First, we have to understand this. So therefore, can you tell what should I write? So I x about this axis. Say I x c x c. What is that? X. This will be actually x prime. So what is that? Here actually it is x prime for this shape. So what is that? Can you tell? But do not be confused that this is x prime is different, right? This x prime is the definition. This is the definition. So that should not be confused. So that is the definition. This is the theory or definition. Can you tell how to transfer? About this axis we know. What is that? Say this is xc1. What is that? I x prime is equal to I xc1 xc1 plus d1 square into a1. This is d1 and this is a1 we know already. And what is xc1 x1? This one. So what is xc1 Can you tell what is that? No, this is the area moment of inertia I am asking. So this is what? This part. xc1 this is nothing but 1/12 of bh cube. 1/12 bh cube that you have to kind of memorize, okay? That part we have to memorize. So for the centroidal, for a rectangle about the centroidal axis, if it is h and if it is b, So about this axis, the moment of inertia is equal to 1/12 of bh cube. So to 1/12 bh cube, how much? B means how much? This one. So it was 200. 200 into h cube. H means how much? 40. Exactly. So this is this. And plus d1 square. D means this one, 43.92. So 43.92 square multiplied by area. Area is how much? 8,000. 8,000. Exactly. So total is how much? Total how much is it coming? How much is coming? So is it clear? First of all, exactly. You are right. Thank you. Thank you. Thank you. I missed it. You're right. Forty cube. Right. You're right. So this is this value 40 cube. BH cube. Exactly. You're right. So how much is it coming? Are you following all of you?
1.67.
1.4
1.649.
649. Okay, okay. 649 into 10 to the power 7. What is the unit? Can you tell? Millimeter to the power 4. Exactly. Millimeter to the power 4. Millimeter to the power 4. Okay, so that you have to clearly understand, because you see y square dA. Y unit, Y square is millimeter square. Again, area has millimeter square. So millimeter to the power 4. You're right. So this is first, this one. For the area 1. This is for area 1. For area 1. So we can write this as Ix I1 1. You can write that, right? This is 1 for area 1. Similarly, for area 2, we can determine using the same rule for area 2. Is it clear to all, everyone? Please, can you confirm that this you have understood? So what we are basically doing, you see, that we are transferring from this axis to this red line, red axis. So for individual shapes, we can determine the moment of inertia for their centroid, means about their centroid, and then we will transfer it to the red. Clear? First of all, is it clear to everyone? Next, what we will do? We will do it for the orange color, and we will transfer here in the same way. For the orange color shape, you see, it is where, again, do the same thing. You can do it, just copy it and then transfer it. So we can do that. We can copy the whole figure and then transfer it. Next, what we will do, we will adjust the lens, adjust the area. Next, for area 1, for area 2, for area A2. Now, A2 is not this, A2 is somewhere else. A2 is where? A2 we will draw. Orange color area, this is this. So we will draw it here. This area. We are now shifting. Area is this one. So we can delete this first area. Now this XC for this area is somewhere else. Where is that? This XC2.
90 millimeter.
Exactly. So it will be 90, means is the centroid of this, right? It will be here. So now we will write that. So this is XC2. This is XC2. So this is 69 and this is how much? This is 90. So the remaining we can delete. The C1 is not needed anymore. We will mark that. This is not needed. This is also not needed. Next, we will mark. This is C2. It is at 90. And therefore, what is this distance?
26.
26.08. And this is what? This is D2, right? This is D2. D1 was this one, the distance between the centroid of area 1 and the centroid of the composite object. Here, this is D2 is the distance between the centroid of area 2 and the composite center of the composite object. Is it clear? So this is D2. And what is A2? A2 is, we know, A2.
3,000.
Exactly. 3000 millimeter square. So can we now write? Therefore, IC IX2 X2 means what? About, for this area to about the x prime axis red, I'm transferring from this xc2 axis. So what is that? I xc2 xc2 plus d2 square into a2. Now you tell me what is this first term? First term is again 1 by 12 bh cube, isn't it? What is b? B means the width. Width is how much?
30.
Width is 30 mm.
30 millimeter.
30 mm, right? 30 multiplied by h cube. H means 100 cube. Exactly. 100 cube plus d square. This will be d2. So d2 square, how much? D2 means 26.08. 26.08 squared multiplied by A2. A2 is 3000. So please calculate and tell me. All of you, please do these calculations yourself. Okay, please do not wait for others to calculate, because this is the practice session also. So have the habit of using calculator quickly.
So 4.5 into 10 to the power 7.
4.5 আর একটা digit
4.54.
54 into 10 to the power 7 millimeter square. Okay. Next, we can determine for area 3 also. Yes. Oh, yeah, yes, you're right. Millimeter to the power. Thank you. Okay. Next, we will determine for area 3. For area A3. Now again, we will copy this and we will paste so that we can understand clearly. For area A3. For this shape, this is the gray color. This is for the gray color area. This is for the gray color area. This is here. Sorry. This is this safe. This is this safe. And we know the centroid of this. That means we will now transfer this through the centroid. Here, this is the centroid. And this is basically XC3. So this is 3 and this is 3. Okay. Achha. What is this is C2 and this is C3. So let me delete the earlier ones. Okay. Now D2 is no more needed here. Okay. So what is this distance? This is centroid. So what is this distance? 155, isn't it? 155. And what is A3? We know. A3 we know. And what is D2 there? D3 therefore? D3 is this distance. How much is this? 150.
91.
Exactly. 91.08. The total is 155 and this is 63. So 63.92. So you can subtract and determine. This is D3. D3 is the distance between C3 and C along the y direction. Clear? So basically this is D3. This is D3. This is equal to, this is equal to basically YC3 minus YC. That you can easily understand. For all objects, you can determine this. And this will be basically the magnitude, that is the absolute value. So you can get the mod of that. Okay. Anyway, so what is therefore XC X prime 3 for the third area? What is that? It is XC3, sorry, XC3, XC3 plus D3 squared A3. Simply, what is this one? The first one, 112 BHQ again, BH cube. So what is that? 112 B means how much? 100. Here it is 100. And H cube means 30. 30 cube. Plus D3 square. D3 means 91.08 squared into A3, 3000. What is the value? Please tell.
2.5.
2.51 into 10 to the power 7
So,
millimeter to the power 4. So individually we have got the values of acha, last thing you please answer that what is this? Please follow, all of you please follow that these things that we are calculating here, these things and this thing, what are they basically? They are not
but
moment of inertia about actually see, in case of moment of inertia, it is moment of inertia about some axis passing through a point. Okay. So you see that this one, this one, this one is the moment of inertia. Okay, let me color with a different color so that you will follow. You see that this is the moment of inertia about the red axis passing through this point. And this is the moment of inertia about the blue axis, this one. Okay, you can color with a different color also, means it will be easy for you to follow. So let me do that. This one, this is a say gray color. Okay, this is a gray color. Okay, this is also gray. Say. You see, this is gray. And here we have this gray axis. What is the meaning? The left hand side that I have highlighted with red is the moment of inertia of the third area about this red axis. And the first term on the right hand side, this is the moment of inertia of the same area about this axis. That means this is the centroidal axis. I am transferring the moment of inertia from the centroid to the some other axis. So this is the centroid of the area 3 and this is the centroid of the composite area. So I am transferring from this to this. So therefore the thing that we are calculating here is basically the moment of inertia about this axis. And I know the moment of inertia about the centroidal axis of the individual shape. So the right hand side, the first term is the moment of inertia about this axis, and I am transferring from this axis to this axis. Okay, am I clear? So that we are doing basically. That means from this I am transferring here. I know about this axis, I am transferring it here. Similarly, for this case, I know you see about this axis. I know about this axis. Okay. About this axis. Is it visible? I know about this axis, this blue color axis. I am transferring it to this red. So that I am doing. So individually you can color that also so that it becomes having the same color, so it is basically orange. Am I clear, first of all? Is it clear? Means all are following properly?
So for each calculated separately.
Yes, yes. That we are doing. Individually we are calculating, then we will simply add. Okay? Then we will simply
Yes.
add. So next we will write for the composite area, that we will write. Therefore, the area moment of inertia of the composite, or you can write I section within bracket composite area about its centroidal axis, centroidal x-axis. What is that? A centroidal x-axis means basically uh, x prime is what is that? Can you tell? Is I x prime is equal to I x prime 1 plus I x prime 2 plus I x prime 3 x prime 3. Okay, is it clear? So what is that? Please tell. What are the values that you have calculated already?
699.
First one was 1.649. 1.649. Please maintain the number of digits so that it will be similar. 1.649. If you are keeping 3 digits, actually it should be significant digits. So significant digit you can, because the areas are measured in millimeters, so significant number of significant digits should be okay. But here you don't have to means do that. You just maintain a number of digits. 1.65 you can tell, 1.65, and then 4.54 and 2.51. So 1.65 into 10 to the power 7 plus 4.54, 5, sorry, 4.54 to 10 to the power 7 plus 1.69. Sorry, 2.51. 2.51 into 10 to the power 7 millimeter to the power 4. So what is that?
8.7
8.7?
to 10 to the power 7.
8.7 into 10 to the power 7, 70 to 10 to the power 7 millimeter to the power 4. So that is your answer. Okay. Next thing that I will tell you one thing, that it can be done, I think, in a simpler way. If you have area like this, I can do it in a simpler way by integration. By simple integration, it will be, I think it will be easier. So I will just show that with simple integration. The same area, I will do it with now simple integration. You will see that it will be, I think it will be easier. Okay. So uh, means easy to follow, I guess. Means transferring all these maybe for you maybe appearing to be little difficult. So I will show that it can be done little easier. So you will judge whether it is easy or not. But to me, it appears that for you it will be easier if we go for doing it like that. Okay. So what we will do basically, we know all the means lengths, we know it. So what I will do instead is I will take a strip like this. So for this area, for the whole area, for the whole area like this, we know the axis. And we also know this one, red area, red uh, axis. That part you have to know first. So this you know, the distance you know, that center you know. That means this distance you know, 69, that 63.92, that you know. Okay. Now what I do is I will, instead of using the parallel axis theorem, what I will do rather is I will take general strip. I will take a general strip like this. You see, a general, any general strip. Any general strip here. Say for example here. Okay. Now what is the size? What is the dimension of this? Dimension is, say, this is in the y direction. So the width is dy and this is, say, x. This is x. Now you see that x has a beautiful nature, that for this one, throughout, x is equal to how much? 200. X is constant. Again, x is a different constant for this part and x is a different constant for this part. So is it clear first of all? That means for three different values of range of y, we can identify three values of x, and these three values of x are constant. They are not, it is not varying. So x will come out of the integration without means making any difficulty. First of all, is it clear? So let me write. So I now will write the values of x. So x is equal to, for this, x is equal to 200 millimeter for the range y is equal to 0 to 40 mm. Next, x is equal to 30 mm for the range y is equal to how much? 40 to 140. Is it clear? And x is equal to 100 mm. Am I clear?
Yes, sir. Yes.
For the range y is equal to 140, 140 to 170. You will see that this will make your calculation much easier. Instead of applying this parallel axis theorem, I guess it will be easier. So I will now write the definition of the moment of inertia instead of that parallel axis theorem, etc. So from the definition of moment of inertia, from the definition of moment of area moment of inertia, to be precise, inertia. Now we will determine directly about the x prime axis. So there is no problem. Now I will calculate directly about the x prime axis. So therefore, what we have to do? We have to measure all the distances from the x prime axis. So what is the definition? Let me zoom it so that you can see all this. So now you see. This is the complete area. I want to determine the moment of inertia of the complete shape, not decomposing and individually determining. I will determine the moment of inertia of the complete shape about the x prime axis. So therefore, I will measure the distance of this strip from the x prime axis. So what is the distance? Can you tell? this distance, that is say y prime. What is that y prime? Can you tell? That is nothing but y minus how much? This one, 63. That is y c, y c, and that we have determined already, y c, y c, simply y c. That we have already determined. This one, you see this one, y c. Am I clear or not? This is y c. This one, y c. So that is nothing but this distance. Okay, is it clear? The distance between the black and the red axis. So therefore, this one. This is yc. This is yc. So therefore, now we can write the moment of inertia about that axis. Is it clear? So x prime is equal to integral y prime dA over the complete area. Okay. Now you see that you can adjust this area, so, adjust this length. Now what is dA? What is dA? Can you tell? dA dA is equal to x dy. X we know, so we can write it here directly. So therefore we can write what is y prime? Y minus yc. Y minus yc into dA. dA means x dy, right? And now what is the value of y? Value of y varying from 0 to how much? 170, isn't it? 0 to 170 total. So 0 to 170 I will write 0 to 170. Next, I will just split this into three ranges of integration. One is from 0 to 40 for this area. Another is from 40 to 140 from this for this area. And the third is from 140 to 170 for this area. So that x can be taken out of the integration because x will be constant in that case. For individual areas, this is constant. Okay, is it clear? Is the strategy clear? Therefore, we can write I x prime is equal to 0 to 40 y minus yc. Now, what is x value of x? We will write. Okay, first let me write. Then 40 to 140 y minus yc. Then x dy plus 140 to 170 y minus yc x dy. Okay, is it clear? We have splitted the limits of integration according to the ranges here. Next what? Next we will simply bring these x values here. Now we will bring these x values here because x will be constant. in that case. So what is that? X is equal to 200 for the first one. 200, 0 to 40, y minus yc. Yc means how much? 63.92 dy. Plus, for the next case, x is 30. So 30, 0 to 42, 140, y minus 63.92 dy. One thing I have missed. I have done the mistake. Can please excuse me? Please excuse me. That this will not be y prime dA. This will be y prime squared dA. I'm extremely sorry. That is the definition. I'm extremely sorry. So this will be square instead of this. Okay. Okay. And the third one is 140 to 170. And then the third one is 100. For third range, x is 100, I guess. And then y minus 63.92 square dy. Okay. Okay, can you solve this now? This will be easier, isn't it? Okay. Am I clear?
So,
Okay. One more thing that you can do for easy calculation of this. One more thing you can do for easy calculation is that you consider y minus 63.92 as equal to y prime. So your dy will become dy prime. Clear? So it will be simply y prime square. And what will be the changes of the range? Can you tell? When y is equal to 0, what is y prime? What is y prime? 60 minus 63.92. Minus 63.92. When y is equal to 40, how much is y prime? 23. 23, isn't it? 23.92 minus y is 40 simply. So 40 minus 63 minus 23, isn't it? Just add it. When y is equal to 140, simply add 100 with this. So y prime will be how much? Adding 100 with this, it will be 76.08. Calculate karo. And when y is 140, 170, what is y prime? Then again we have to add 30 with this. So it will be 106.08. Basically, I am transferring this axis from this. That means black to red. So y prime, simply y prime. Clear? So that you can calculate. That means what? This individually you don't have to go for this calculation. You will just transfer the range and you can easily calculate. So therefore you can write I x prime is equal to, you will just change the range. So what is that? Minus 23.922, sorry, minus 63.922 minus 23.92. The first range. Minus 63.922 minus 23.92 y prime square dy সামনে আছে 200 plus 30 multiplied by minus 20 30.92 276.08 y prime square dy plus 100 multiplied by 76.08 to 106.08. How much is that? Y prime square dy. Now what is the value of y prime square dy? Simply y cube by 3. So 200 multiplied by y cube by 3 for minus 63.92 to minus 23.92 plus 300, sorry, 30 y prime cube, sorry, y prime cube by 3 minus 23.92 to 76.08 plus 100 y prime cube by 3 76.08 to 100 6.08. To 106.08. Okay. How much is coming? Can you tell? 200 into minus 23.92 cube 3 can be brought here. Minus 23 and then minus of minus 63.92 cube plus 30 by 3 76.08 cube minus of minus 23.92 cube plus 100 by 3 106.08 cube minus 76.08 cube. How much is it coming? Please calculate. Are all of you following? I can understand that it is continuously about 2 hours we are running the class. It may be little difficult, but still, please, if you have any doubt, please ask. Okay. Are you calculating? How much?
6, 7, 7.
1.64 into 10 to the power 7 plus 4.54
154.
10 to the power 7. Is it coming to the first? Uh, okay, okay. And then third one is 2 point. So it will be finally 8 point something was there, right? 8 point
7.
8.70 into 20. So uh, you can see that, sorry, 10 to 8 millimeter to the power 4. So you can see that means you can adopt any method, but to me it will be easier, isn't it? Just doing integration you need, means whatever you find easier you can adopt, but for me I think it will be uh, easier for you to do. Am I right or not? Means instead of doing many teachers suggest that it can be easy, that if you go for applying the parallel axis theorem, you can adopt that. Whatever you find easier, you can adopt. Okay, I demonstrated with the both the methods, so you can adopt any of them, and answer definitely will be similar. Okay, so this is one thing. That means regarding the moment of inertia of the I section. So we could do it, and the moment of inertia of the T section is done in one video. I have given that. For that also I have demonstrated with both the methods. So you can see that T section. I have added that. Okay. So moment of inertia calculation. So far we have done for these two sections. Also, L section you can do similarly. L section means like this. You can do like this, for example, L section. L section like this. For this case, you can understand that this is actually not symmetrical. So in that case, the x and the y coordinate both you have to determine instead of simply the x coordinate. You have to determine for x and y both. Following the same rule. Rule is same. Only thing you have to determine for both. Because it will be uh, means for this area, you can easily understand that for this area, that means for this area and for this area, the centroids, that is x coordinate of the centroid are different. For this, it is somewhere here. For this it is here. Therefore, the x coordinate will be coming to be on a different line. It will be coming somewhere here, in between, like this. So for this type of shapes, you have to determine both the x and the y coordinate. Also, for example, if you have a shape like this, say C section. So in that case also you have to calculate the x and the y coordinate both. You may have a C section like this. In that case, you have to determine x and y both. For your practice, I have shown with T and I section. You can practice these two, but remember that L section, C section, you have to determine both. Okay. Let me see some other problems are there or not. You can at least practice these problems. Okay. Practice more and more so that you can do it in one run, right? You don't need to mean so that you don't lose time during examination. Before that, you practice a lot. Okay, clear? Is it clear? Hello? Okay. Any questions from you? Okay, one more thing that I will just briefly tell you here. Uh, There is a concept called the radius of gyration. Do you know that? There is concept called radius of gyration. If you have some shape, any shape like this, so you have any shape like this, about some axis, if we want to define the moment of inertia, so for example x and y, the area of this is A, and the moment of inertia of this about this axis, say, is I, then I can write this in terms of this, that is y square dA. What is dA? dA is this area, and this is y. We know that is from the definition. Again, we can write the same as some k square into A. So you see that there is a similarity, right? K square A. So what is that? What is the meaning? That as if I can assume that there is a distance k, or there is a distance k here from the axis x, such that if I consider the whole area to be concentrated at that part, at that point, concentrated at that point at area at a distance k from the axis, then it will produce the same moment of inertia. So k is the distance from the axis concerned at which, if the whole area A is placed, means at a point, then it will produce the same moment of inertia as equal to the distributed area. What is the meaning? That this is the moment of inertia for the distributed area, and this is the moment of inertia for the area which is assumed to be concentrated at a distance k from the axis. If these two are same, then this distance k is known as the radius of gyration. This distance placed, whole area placed, means it is concentrated, assumed to be concentrated. assumed to be concentrated. This distance K is called the radius of gyration about radius of gyration of the shape the area or shape about that axis. Okay. So I will not discuss any more means from my part because I think it is about 2 hours or more. So if you have any specific question, you can ask, or we may leave. Means if you have question, I can definitely answer. If you feel that there is a question, you can ask. Because you are not interacting, I am not sure that whether you are listening or just means muting the mobile, and some of you at least. All of you are following. Please answer.
Yes, sir.
And
Yes, sir.
anyone else? Okay, you have noted. All of you have noted whatever I have written. Please note this, okay? Because you have to means write yourself. Then you will it will be easy for you to do it. Okay.
Sir, can you repeat what is that K?
K means basically radius of gyration. So basically what we are doing, you see that I have shown one shape or area here and one axis x. Now I can determine the moment of inertia of this area about this axis from the definition. This is the definition, the top one. I is equal to integration y square dA. What is that? dA is the elemental area and y is the distance of that area from that axis. And if I integrate this over the area, I can get the moment of inertia. Now, I can assume that this area is as if instead of distributed area, so for distribution, I can go for integration. Now, if the area is assumed to be concentrated at a point, then I can calculate the moment of inertia like this. Then in that case, I need not integrate, isn't it? So k square dA simply I can write. Because this area, there is no change of y. So I can simply integrate this and that y will come out. So therefore, this can be written. So if there is some distance measured from this axis such that if I consider the whole area to be concentrated at that point, then it will produce the same moment of inertia. So that is basically the radius of gyration, and you can determine that radius of gyration here by using this. So what is that therefore? You can therefore calculate that k is equal to root over I by A for area moment of inertia. For mass moment of inertia, it will be I by M, right? So this is the definition. This is the definition of the radius of gyration. Okay, root over I by A. So if you can determine, or if you know the, say for example, if I ask you, say for a simple figure, if I determine for some simple figure, if I say determine the area, say for example this one, this area, and say for example this is the axis. Sorry. This is the axis for which I want to determine the radius of gyration. Okay. Now this is say, as we know that this is B and this is H. This is X direction, this is the Y direction. So now what is the moment of inertia of this area about this axis, can you tell? So what is Ixx? It is 1 by 12. Sorry, 1 by 3. 1 by 3. About the edge, it is 1 by 3 BHQ. About the centroid, it is 1 by 12. About this line, it is 1 by 3 BHQ. Now, what is the therefore radius of gyration? Radius of gyration is K. Now, what is area? Area is equal to BH, isn't it? Area is equal to BH. So, what is the radius of gyration for this area? K is equal to I by K is equal to I by area. So, what is that? What is I by A? BH cube by BH. So, it is basically 1/3 BH cube by BH. So, what is that? Can you tell? H by root 3, isn't it? BH will cancel, H square will remain. So, H by root 3. So, where is that? Can you tell? What is root 3? Can you tell? This is what? H by 2, isn't it? H by 2. So, where is H by root 3? Can you tell? Huh? H by, which one is more? Which one is more? H by 2 or H by root 3? H by root 3 will be more. So, therefore, that centroid, that point will be somewhere. That line will be somewhere. I can draw H by root 3. If I draw an arrow, it will be somewhere here, isn't it? H by root 3 means root 3 H by sorry, H by root 3 means about how much? H by root 3 means H by root 3 means 8 1.7 1.7. So 1 by root 3, right? 1 by root 3 means how much? Can you tell? 1 by root 3? One by root 3 is about
0.57.
huh?
0.57.
0.57. Okay, okay, right. So you see that this is about 1. So this is 1 and this is 0.5. So 0.57 will be close to zero point 0.5 definitely. So it is not that much away from zero point 0.5. So it will be somewhere here, isn't it? Right. So one thing is this, right? Another thing is that what is the radius of gyration about this y-axis? So can I write that this is moment of inertia, this is the radius of gyration about the x-axis. So I can write here as kx instead of simple k. I can write kx. So this is basically radius of gyration about the x-axis. Similarly, you can determine the radius of gyration about the y-axis. What is that? So this is Ixx by A, isn't it? Now it will be therefore Iyy by A. And what is Iyy? Can you tell? In the same way, Iyy will be 1 by 12, 1 by 3 hb cube. 1 by 12 hb cube. Sorry, 1 by 3 hb cube. So it will be therefore 1 by 3 hb cube divided by bh. So what is that? B by root 3 instead of h by root 3. So ky is b by root 3 and kx is h by root 3. So again it will be therefore somewhere here. It will be somewhere here. It's just little more than 0.5. It will be somewhere here. That means I can identify this point. I can identify this point. Therefore, this is the radius of gyration. This is kx and this is ky. This is kx about x-axis. This is ky. So therefore, you can easily determine the radius of gyration for any shape. Now for the centroidal axis also you can determine simply instead of 1 by 3 it will be 1 by 12. So from the centroid how much is it you can determine. Right? Clear or not? Is it clear?
Yes, sir.
Okay. A simple I am just asking you some simple questions. So try to answer. Uh, say you have a ring like this and you have an area like this. Means if you have a small ring like thing, the area is A and this is area is same area is A. Okay, say for example. So instead of mass, it will be easy. So what is the area moment of inertia of this? Can you tell? First, you try to answer this one. Say is area is pi r square, pi r square, and the radius is r. So if we want to determine the moment of inertia about this axis I. This is the x. This is y. So I x x and I y y. So for this it will be a r square by 2. For this also it will be a r square by 2. Y y. Sorry, you can determine that. For z axis it will be a r square by 2. So it will be a r square by 4. A r square by 4 instead of a r square by 2. Sorry. Okay. So how to determine? You can select any two strips like this. Like this. So this is the area. Say for example, this is, so this is the strip, and you can, what is the area of this strip? What is the area of this strip? Say dA. What is the area? dA is equal to 2 pi r, say r prime. This is r prime. From the center it is r prime. So r prime dr prime. 2 pi r prime dr prime. So this is area. So you can write next, what is the definition? I say about this perpendicular axis if I determine, say I z z if I determine, what is that? About this axis, about the axis which is perpendicular to xy, that is I z z. What is that? The distance. So what is the distance? R prime square d a over the whole area. Sorry, yes, over the whole area. So r prime square, what is dA? dA is 2 pi r dr. So 2 pi r prime dr prime. What is the range? 0 to r. R varies from 0 to r. R prime varying from 0 to r. So what is that? So 2 pi r prime square dr prime, 0 to r. So 2 pi r prime cube. Okay, r prime cube. I'm sorry, r prime cube. R prime cube, r prime square and r prime square. So r prime, so r prime cube, then it will be r prime to the power 4 by 4, 0 to r. So it will be 2 pi into r to the power 4 by 4. So it is how much? Pi r square, I'm sorry, pi r square by 2 pi r square by 2 into r square, you can write. So it is basically 1 by 2 a into r square. So about z axis, this is about z axis. Now we know that this is equal to izz is equal to ixx plus iyy from perpendicular axis theorem. And again, ixx and iyy are same because this is symmetrical object. So therefore we can write that izz is equal to ixx plus iyy from perpendicular. And ixx is equal to iyy because of symmetry. Therefore, you can write that izz is equal to 2ixx or 2iyy. So therefore, what is ixx? Ixx is equal to izz by 2. That is 1/4 a r square. The same as izz, iyy. So therefore, we can write for this circular area, we can write this for this circular area. About this axis or about this diametral axis, ixx is equal to iyy is equal to a 1/4 a r square, and izz is equal to half a r square. Okay. So I think we should conclude today because it will be too much for you. But if you have any question, then I can answer definitely. But otherwise, you can close. You may be feeling bored. It will be too much in one day. Okay. If you have any question, then you can ask or you may conclude. Okay.
Okay, sir.
Okay. Okay. So if you have any other questions, anyone else, or can we or should we conclude? Time deep. Shayandeep, Shubhodeep, Sumon, Ayushi, and then
Yes, sir.
what? Who else are there? Others I have gone, I guess. Tompati, Devraj, Swastika. Okay. If you have no question, then we can conclude today. Okay.
Yes, sir. Yes, sir.
Okay. Regarding regarding moment of inertia, any more classes needed? Then we can take a different class on on the next day. Okay. And also one problem I will solve. I will try to solve in a video. That is the problem of the intersection of the parabola assignment 2. That problem I will solve in one class, maybe after the vacation. Before that, can we arrange two more classes on dynamics? Okay, please talk to yourselves and then confirm me. Okay. Okay. I think dynamics will be required. So some classes on dynamics can be arranged. Okay. Okay. Thank you. Okay, I will send some problems and you please solve them and submit after the vacation. Okay, I will send a set of problems. Okay, thank you.
Okay.
Thank you.